Hello everybody. Today we're going to look at the second part of section 2 of chapter 2. We're still looking at velocity and momentum. Here's what we did the last time. We talked about velocity, the fact that it is a vector unlike speed, which means it has a direction as well as a magnitude. All right. We also talked about relative velocity. Your velocity relative to other objects around you, and we looked at how to do that, and we've even practiced it. All right, and there was another example. Now today we're starting right here, okay? And we're going to be looking at a quantity that moving objects have called momentum. Now, interestingly enough, momentum does not use an M to represent it because we already use an M for mass. So momentum actually uses a P. P for momentum. Now, is that weird or what? But that's just one of those things, okay? Momentum. Now, momentum is a way of looking at the inertia of an object, its tendency to resist changing motion. So your inertia resists change in motion, and the more inertia you have, the more momentum you have when you're moving, okay? Momentum is simply the product of an object's mass and its velocity. So right here, let's write that. Now remember, product in math means to multiply. So if it's a product, we're going to multiply mass and velocity. So mass times velocity. And this is how we'll calculate momentum. Okay? So remember, product means to multiply. And that's a good way to remember anytime you see product that you're going to be multiplying things. All right, now what about the units for momentum? How do we measure it? Well, in order to see how we measure momentum on this side, we have to look at the units that we're using over on this side. That's what's going to tell us. Well, mass is measured in kilograms. Remember, that's the SI unit for mass, not the gram. All right, in physical science, we use the kilogram. Velocity, just like we said right up here, velocity is in meters per second. So we're going to multiply kilograms times meters over seconds. So basically, you end up with kilogram meter per second. And that's the units for momentum, okay? SI units for momentum. There we go, SI. That didn't turn out too well, did it? Because I'm writing on a tablecloth. It doesn't do too well. All right, look at this example. It says, at the end of a race, a sprinter with a mass of 80 kilograms has a velocity of 10 meters per second east. And we want to know what is the sprinter's momentum. Okay, well, let's go through our three-step process. The first thing is we identify what we have, okay? Mass of 80 kilograms for our sprinter. So let's write it out. Mass equals 80 kilograms. So we've identified it. Velocity of 10 meters per second east. So 10 meters per second east. I'll just put a capital E for east, okay? And we're trying to find the momentum. All right, so step 2, we write the formula and plug in the numbers, but always write the formula without the numbers first. So we get mass times velocity so that you can see what goes where. So we get 80 goes in the M's place. Now we plug in. See, write first, then plug in. Times 10 meters per second east. Okay, now the numbers, the magnitudes, we just multiply. So 8 times 1, and remember, anytime you multiply by 10, you're just going to make this bigger by 1 decimal place. So 80 becomes 800 if you move the decimal once. So we get 800 kilogram meter per second, and the direction is east because momentum is a vector like velocity, okay? In fact, oops, that was step 3 right there. Boop. In fact, it is important to note that the momentum is always the same, there's the clock again, direction as the velocity, okay? Has to be, because when you say mass times velocity, the velocity gives the momentum its direction, okay? Okay, there we go. Now, let's see what happens how things are affected by mass and velocity. Let's talk about how momentum. If we take a look at this formula, if we make the mass bigger, if we had, say, doubled the mass, made it 160 instead of 80, that means we'd get 1,600 kilogram meters per second squared. So if you'll notice, if the mass increases, so does the momentum, okay? Likewise, if we had said the object was moving at 100, double the speed instead of 10, all right, or 10 times it, well, double is 20, yeah, all right, so 20. 20 times 80 would be 1,600 also. So if you increase the velocity, you increase the momentum. My tongue's getting all twisted, sorry about that. Increase one or the other, you increase the momentum, okay? Now, let's talk about some interesting things. If you have an object, you don't normally change the mass of the object, but you certainly can change its velocity, okay? Now, an interesting thing, and some of you may, I like to use this example because some of you may be skateboarders, okay? An interesting thing happens. If you've ever been on a skateboard, you may have noticed this happen. You're rolling along on your skateboard and you jump off to the side or maybe to the back. And when you do, all of a sudden your skateboard takes off. It accelerates forward and you have to run after it. If that's ever happened to you, it's happened because of momentum. All right, here's why. And we can write this down. What you can do is you can listen and let me write it and then pause the video and then you can write it. That way you don't have to try to keep up. Doesn't that sound good? Okay. So basically here's what happens. When you are on the skateboard, you and the board share a momentum because you're like one object stuck together, okay? All right. Now, when you jump off, now you're going to stop when you jump off, so you don't have any more momentum. Now the skateboard has all that momentum, but less mass. All right? Because you're not there anymore. So all that momentum for just the skateboard instead of both of you. And since the mass has decreased, to keep the momentum constant, because momentum is always conserved, to keep the momentum constant, the speed increases. The speed increases to keep the momentum, and I'm just going to abbreviate it, the momentum constant. Oops, running out of room. To keep the momentum constant, okay? That's why it takes off when you jump off. you leave all your momentum behind because you stop when you jump off the side. So the skateboard having all that momentum but less mass than before, to have the same product with less mass, this has to get bigger. The speed has to get bigger so that when you say speed times less mass, you get the same momentum that you had before. So it has to be a bigger speed in order to get the same momentum. And it takes off and leaves you behind and you have to chase it down. I know, I've done that before myself. And yes, we had skateboards back when I was young. All right, so now, can two different objects have the same momentum? Yes, they can. Oh, by the way, if you need to pause and write that down, go ahead and do so. All right, let's look at this. Let's look at this. Mass 1 and mass 2, the semi and the car. Can they have the same momentum? Yes. Mass 1 can have the same momentum as mass 2 if, there's always an if, right? If it has a much smaller speed than mass 2. So in other words, to have the same momentum, the bigger mass must have a smaller speed, and the smaller mass must have a bigger speed so that the two momenta are the same. So yes, they can. Okay? All right, that's it for now. Tomorrow you're going to watch a really great video. It's called Understanding Car Crashes. And this is a video that I give or show to all my students every year. It is a really great video because you get to see car crashes. It's all done at the Institute for Highway Safety. And they show all different kinds of car crashes. And while you're watching the video, make sure to note that the majority of these car crashes are anywhere from 25 to about 40 miles an hour. Just regular in-town type speeds. I'm not even talking about speeds like on the interstate. I'm talking about what we would consider to be slower speeds. And wait till you see what happens. It's really kind of cool. Also take note of the make and model of cars that don't do so well during the crashes. And you're going to learn a little bit about momentum while you're at it, okay? They even have some crash dummies in there. It's pretty cool. All right, well, I'll leave you to it. And you guys have a good day and a good week. Talk to you soon. Bye.